Some students ask me about deep learning, so I explain more in details here. The first one is based on the deep learning. Okay. I think you can focus on the VGG16 because the net, last time I talked about the net is 2 plus 3, so the net file is 2 plus 3. It's not complete. Not complete. AlexNet is 5 plus 3, but the 5, because it only has 3 downsampling, so it's the 5 is okay, but it only 3 downsampling, so it's incomplete for the deep learning. So the first one is more complete. The deep learning is a VGG16. VGG16. Why? Okay, so we talk about this one. So this is a kind of a VGG16. VGG16 is they have a, if I want to explain more in detail, VGG16 will be here. So this is a page 26. 26, this one is a VGG16. Okay, so I explain this one, 26. So I explain this one in detail. So assume the input image size 224 by 224. This input image size. Your first homework will include the deep learning. So you should learn deep learning. But actually that's the purpose for this class. So the 3 is the 3 channels RGB. So they have a image size is this one, 224 by 224. But it doesn't mean you need to this one right now because we have a GPU probably 2080. So you can have a like 512 by 512 is also fine. You can have a bigger image is fine. So the input is 3 channel, it's RGB. If your input is only 1 channel, it's D. It's D. So sometimes only 1 channel is fine. That's. But some people use this one for the depth image. They will do D, 3D, copy to 3 times. It's also fine. Okay. So this input. Okay. So this is 16. Why is it 16? It's 16 is because I said here it's 13 convolution. So 13. So before this one, before here. So before here, there was 13 here. And after here, it's 3 layers. 3 layers is for neural network. What's the 3 layers? Is so after here. So before is 13. After this one, it's 3 neural network. So here, this output here. So first one is this one. So we have 1 here. This is this one. 40, 90, 96. They have 40, 96 elements here. 这有4096个 element here. 那在这个前一层这里，这 flatten 是这个，这是7 by 7 by 512. So they will do connection. They will do connection here. Fully connection. So this one flatten is here. And final output is because in this case, the output want to classify to 1,000 classes. You want to classify to this one. You want to classify to 1,000 classes. So each one will connect. Fully connection. And this one is also connected. So this is 1,000. This is 40, 96. Okay. And this is flatten this one. So it was 3 layers here. So here. So remember is to this one. Anyway. And 13 is here. So it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, so. So is this something wrong? This one. This is a VGG. Oh, this is VGG 19. Okay, this is VGG 19. This is VGG 19. 1, 2, 3, 4, 5, 6, 7, 9, 10, 13, 15. Still wrong. Okay, anyway, there's something wrong here. So I say again. So this one, they have a from 3, right? They do the conversion to 64. So it's 64. So if we go back to the previous, we talked about this one here, right? Only we have a 1, becomes 6, and downsampling, and become 16, and then downsampling, and fully connection. So based on this one, the same here. But here I say it's more complete is because they do convolution and then do downsampling. So here downsampling. The red color is downsampling. So they downsampling 1 time, 2 times, 3 times, 4 times, 5 times, 5 times. So right now, almost all deepening, the downsampling is 5 times. But for between the downsampling, they have a different kind of convolution layers. 它去做 convolution 这样子。So see here, this is the size here, and after downsampling, see the layer is more, the channel is more, but the size becomes smaller, right? The channel number is double, and the image size is or map is reduced to half. So become half and increase channel, half increase channel. And finally this one. But here, because right now computer is more powerful, so here many different they use 1024， 就是变成512变成那个1024，这里不是512，像这里有就是 many layers here is they have a 1024. The other issue is be careful is this paper is already old, 5 years ago. So right now this size is bigger. So this one actually, according to recent paper they talk about, 7x7 is too small. 7x7. So right now the output here, because this is double size, so here the final one become 14x14 by 1024. 就是说，目前因为这个 size 可以变大了，所以这个7x7 recent paper talk about 7x7 actually too small. So if your size is this one, probably your downsampling can be only 4. If the input size is like this one, actually we don't need this one. Your downsampling is up to here. It's good enough. Just 14x14 because 14x14 already very small. Okay. But the problem is why if we do 14x14 by 1024, this flatten here will be very big. 这是变成这10乘10乘那个1.24的话，这个就会很大。So sometimes you need to consider your classification. If you classification you need to classification here, and probably this is better. So the answer is this one. If you only do the classification 7 by 7, this is okay. If you want to do this one, you want to do the reconstruction, you can use probably 7 by 7 is too small. You can do 14 by 14 by 1024 and then reconstruct it to here. So if you only want to do the classification, the smaller is okay. But if you want to have the convolution, deconvolution, probably this size is too small. Too small is meaning you will lose your information. You will lose your detailed information. So I continue to say that. So this one actually is this one. It's for encoder. And this one is for decoder. So the different part is this one. So this one is meaning what? Meaning this two, the only connection is fully connection. That's meaning so here is flattened, this one, and this one, and then do fully connection. So the size, see, this is 7 by 7. So it's 49 here, and it's 49 here. Why this is not good? Because this connection, neural network connection, this part, the size is fixed because this size into 7 by 7 into flatten, flatten 就是把它拉成一定flatten. This has a 7 by 7 is 49 cells. This 49 cells is fixed. So if you change the size here, you got problem here because here they only allow 49. So this fixed. So if you do fully connection on network here, your input size cannot be changed. So what can we do? We will do is do convolution. This one. Don't do this one. Just keep convolution is meaning your convolution filter size can be 3 by 3. So no matter, the input size is just the input size, no matter how big or how small it is. Here doesn't affect because here you do convolution. So the convolution, the filter size is only 3 by 3 or 5 by 5. So no matter you don't do flatten. So here is flexible. So that's meaning your input image size will be flexible. So that's the advantage if you do convolution here instead of fully connection here. 看懂吗？你这里也是 convolution 继续做下来的话，你这个 size 就可以任意 size。你有用 convolution 就是这样 flatten 来做的话，这个 size 没办法改变。所以这个是这边的优点 ，convolution 的优点。好，这是要跟你上次跟你提的。The second one is because you do downsampling here or lose detailed information, so we do shortcut here. We do shortcut. So because here we'll lose the detailed information, so we have put the information shortcut. Shortcut is mean the information will combine to here. So you have information from here, also have information from the previous layer. So this is good for shortcut. Okay. So last time we talked about this one. To explain this one. So this one. So after we talk about VGG 16 or VGG 19, people don't use XNet. Like I said, most people don't use XNet because XNet is not robust enough. So they use at least they use the VGG 16 or VGG 19 at least. So this is one case that we use the VGG16. So we have one downsampling, 3, 4, 5 downsampling. But if you use the XNet, they only have 1, 2, and 3. Okay. And talk about the downsampling. Sorry, okay. Talk about the downsampling here. This one. It's page 26. Talk about downsampling. What's the maximum pooling? Maximum 2 by 2 maximum pooling. Maximum pooling is meaning if you have a for every 4 pixels, the window, right? And they have the pixel value or map, we call map value, 就每个 pixel 都有个词嘛，对不对？ So 4, you just pick up the maximum one. So that's called maximum pooling. This 4 value you pick up for every 4 pixel here. You pick up the maximum value, become 1 pixel here, and shift next to 4. And you pick up the maximum value to here. So downsampling. Okay. So the downsampling easy way is just to just maximize the meaning, to pick out the maximum value. Again, why we select the maximum value is because there's a convolution. Convolution, we try to extract the good feature. What's the good feature? What's the important feature? It's a high gradient. What's a high gradient? Is meaning that you have suppose you have corner. So the grade value change a lot. The corner, the edge, those information, you can extract those information like edge detection. So high gradient value is important feature. High gradient texture, high gradient value important texture. So we extract the important texture. So we pick up the maximum value. Some people use average. You sum together and divide by 4. Use average for each 4 pixel. They do average. But people already prove maximum pooling is better than average pooling. For previous stage or previous block， 在前面的 block 你在做的时候 ，maximum pooling 的值会比较比 average 还好，所以没有 maximum pooling 这个意思。所以这个大概解释完了，那回到这一边。This one example. What's the advantage of use the network? So in the robot, we try to detect it. So suppose we have a 4 rotation angle. For the object, we have 4 rotation angle, suppose. Okay, so we have 4 rotation angle here. But 4 probably is not good enough. Sorry, in this case, it's 18 angles. Spark 的角度就是180 spark 18 angles. So 10 degree be 1 angle. Suppose output is, so that means your output has 18 classes. Your input, how can I measure what's the rotation angle of this object? Suppose we have 18 angles here. So every 10 degrees, 1 angle. So this output will be 18 classes. So if we not only try to estimate the angle, if we try to also try to classify the object classification. So what can we do? You have 2 purposes. One purpose is for the rotation angle estimation. The other purpose is for the classification. So if you have a network like this, and this is NX, 1, 2, 3, 3 downsampling, or use VGG16. And it's for last three is for classification and network. Okay. So one thing to support, you have this one is for angle estimation. The other one, suppose, is only 4 classes, so upper will be 4 classes for the classification. How can you combine both together? Your purpose is multiple output. One output is for angle, rotation angle estimation. The other is for classification. So if this one is for angle classification, the other, the same network, but you do different kind of training. The parameters will be different. You do classification. Can we combine both network together? Yes, we can combine. So that's a good thing for this one. In page 39. In page 39, we call multitask. So the good thing for the network is you have only one input. You can do both angle, different kind of classification. One is for angle, the other is for the object classification. But you just use one network. So you combine 2 networks to be only one network. Let's see this one. So I training this one first. I training the angle first. And then from here, if I do classification, that's not good. Why? Because your extraction information will be different. Okay. So this 3 neural network, this 3 is for classification. This 3 is also for classification. So we keep it. That's okay for classification. So if we, from here, this for angle, if we can connect shortcut here to here for classification, the result will not be good because this network is only for classification. So what can we do? So we can have one more layer for feature extraction. So this one, feature extraction. So let's fit up to here. So this feature is for angle classification. We do this one to here. This feature is for the object classification. So we need at least one more layer to extract different features for the classification purpose. So we try this 2 layers to see if there's 5 layers here and 2 layers here. Because in this case, it's only 4 classes. It's easy. So we find if we use 2 layers here, the result won't be better. So that's why we use only one extraction layer here. If we have more classes here, probably we need more 2 layers or 3 layers in order to have a better result. So this you need to try. But what I say is because this is already all the paper, the lab we do this one, we combine this one. So we are successful to do this one. Okay. So the good thing is that the advantage for a network is because they can combine together to be one network. That's called multitask. So we continue this one. So this is basic. That's why I said it's a basic. So if you use the support this complicated network, if you do multitask, you're getting more complicated. So that's why I tell you, complicated network doesn't mean it's good. It's good because when you try to modify this one, it's not easy. So simple network is easy to modify. Okay, so continue. So last time we talked about here, and then we continue here. And we talk about softmax data. So loss function is important. loss function. The other one is the output. Here I explain to you is for how do you design the layers, how do you design the downsampling, and what's the meaning for classification made by network, what's the meaning for extraction. So this part is for extraction, this part is for classification. This is basic deep learning. And this one I try to tell you is we have a 2+6 and this more AlexNet. This one. So AlexNet improves the count, and VGG16 improved AlexNet. And for the output here, so I feel this is correct, and this is incorrect. 这是有点错，这个不知道是从哪边学生从哪边看，这有点错。我印象中是这个才对，就是说 this will be one layer, two layers. In this case, in this case only 2 layers. In this case only 2 layers. And this is not there. This is for flatten. So in this case, network only 1 and 2. So this flatten. In this case, correct. So this 3 layers. So 2, 14, 96, 2 layers, and 1 more classification. So here, I say again, the output is this one. So output is this one. So the final output is this one. So here is 1,000 classes here. And this is, we draw in the other way. So this 9 is equal to this 9. Okay. And the output is probability. So summation of all probability is 1.0. The summation of all output classes, the probability, summation probability of all output classes is 1.0. So if this cat, this is a cat. So 1,000 classes, this will be cat here. This will be cat. And other will be small. But for the labeling, for the training for labeling, we have only one. Others are 0. For training, only one class is 1. Others are 0. For the test, they have a different probability, but we pick up the maximum one, and the maximum one should be bigger than 0.5, and there will be your answer. So this is network. So output is only this kind of distribution. This one kind of output. The second kind of output is the output will be 1,000 heat map difference. I say again, there are 2 kinds of output based on what you design. First output is only like a distribution. Okay, and then this is the B. So the summation of the probability is 1.0. The second output is a heat map. So you try to classify 1,000 classes, your output will be 1,000 heat maps. 1,000 heat maps. 这样子。两个不一样。So which one is better? So if you want to do this way, your input here should be a page, a small page. You cannot input entire image, because if you input entire image like this one, you input to here, they have 2 classes. But in this case, they will assume there's only one object inside. So for the first one, if you want to do this one, then you need to do the page. For the original image, you should plot the page. So they will, and for each page, they will try to understand whether there's which class inside there. So in this case, usually you have 1000 classes, you need to plus one. Plus one is what? Background. Because sometimes there's no object here. So sometimes when you read a paper, they will say, okay, suppose I have 1000 classes here, but my output will be 1000 plus one. Yeah, the last one is for non-object. It's for background, because sometimes your input is nothing there or unknown object here. So this is for this case. For this heat map, you can input entire image. Okay, and the output, suppose the output is to a dog and a cat, but because your output is 1000 heat maps, each heat map represent one class. So in this case, your heat map belong to cat. There will be the Gaussian distribution here. You will have a peak here. So this method will belong to cat, and the position is here. So this kind of case is better because heat map is better because they not only do the classification, they also try to show you the position of the object. 它会把你的位置找出来，把 object 分出来。所以在这1000个 heat map 里面，就只有两个很大的高兴。One is for 1000 heat map. If the heat map belong to cat, there will be pig here. If the heat map belong to dog, there will be other heat map here. Other classes, the value is very low. 都很小. So that's nothing about for the other heat maps. So this is better. However, there's more parameters here. A lot of parameters here. So it will take more time for the training. Okay. So the weakness for this one is more parameters. 这样知道哈，我 output 有这样，so output has two kinds of these two types. So we already talked about this one. So this is the same. This is a VGG16. Okay, but for the face detection is it face or not face. Okay, so they tell you that this is the detail features for small window, and this middle one, the middle one is for geometric information. The global one is for symmetrics, the entire geometric information and geometric information over entire images. So they have a local, median, and global. Global information also called semantic. 就语义啊，像语里面藏什么意义是几个位置。So this here they call semantic. Also is called global features. This means they have a geometric information. Like the eyes is above nose, mouth is below the nose, something like that. Okay. So we keep going. So this one is VGG16, right? VGG16, and we have 5 downsampling. So when any network you study the paper, when you try to understand the paper, easy way is that for any downsampling, you cut here, cut here. So you'll find they have 1, 2, 3, 4, 5. They have 5 downsampling. And this is for feature extraction. And this is for classification. So try to do this one. Okay. So this is GoogleNet. What I say is that VGG is more deep. It's more deep. It's VGG. The Microsoft people do more deep. Google people say deep is not beautiful. Thin is not beautiful. It should be a little bit fat. 太瘦不好看，胖一点点。所以 Google 主张要胖一点点，就这个。所以它的那个 inception field 会比较大，对 receptive field 会比较大，就是我们来讲，好 ，let's say this will be 1 unit. So any previous any there, if it's given, sorry, if it's a VGG, it's only one direction. VGG is only one direction, without fat, without wider. Okay. Google Net is wider. It said, I want to extract more information, use different size of filter. So they have their filter size has 1 by 1, 3 by 3, 5 by 5. Here, the filter size only 3 by 3. From beginning to the end, the filter size all are 3 by 3, 3 by 3. People at Google said that's no good. But my experience, this result is better than this result. That's my experience. This result is better than this one. 这是我的经验。We use this because this one is better than others. So sometimes you can use ResNet. So I still feel ResNet, based on ResNet, and you modify ResNet, this is good. This is very good. Okay. And this either one is okay. But this is not easy to modify. This is easy to modify. But the result, this one, basically this is better than this one. And ResNet is better than both. It's my experience. Okay. Back to here. Okay. So how can I classify this one? If you have a network like this one. So here is 1 unit. See, it's 1 unit. So this one, we call 1 module. So each module, we have a 1 by 1 convolution, 3 by 3 convolution, 5 by 5 convolution. It's good because you have a different filter size to extract the same image, the same map. 你用同一个 map， 我用不同的 filter 来做。So what's the purpose for 1 by 1? 1 by 1 is to change the channel size. So suppose this channel here is 32. To here, sometimes I can reduce 32 to 16. So I can reduce the channel size and do convolution. So I can reduce the parameters. So I can reduce the channel size. So I can reduce the parameters because he's more wider. Okay. But here, I still don't know why they do want to do this one. 这个我到目前也想不清楚。这个解释得通，这里有解释，但是你可以做 maximum， 你可以读 maximum pooling 到 centering 的。这个我一直解释不通这里。你们如果通，你这教我。但是它这个是一个 set， so this is 1 set, 2 set, 3 set. So after the 3, 1, 2, this is regular, and 1, 2, 3, and then output here. So this kind of a Google Net is they train to here and do classification and fix the parameters here and add more. 1, 2, 3. Okay, so see 1, 2, 3 and output. 1, 2, 3 output. 1, 2, 3 output. So the same, they repeat. So this become one stage. I call this 1 block, but it's become 1 stage, 2 stage, 3 stage. And for each stage, they train this one and then fix the parameters and train this one and fix the parameters. So 它这个 parameter 不是，它这个是一直叠加上去哦。它是先在这里做分类，然后把这个分类结果出来，哎，没那么好。Here the result is okay, not so good, but okay. So they gotta fix the parameters， 把那个 parameter 参数都 fix 了，然后再加一层，再加一个除进来，哎，结果比较好 ，it's getting better and better. And for the test, they remove this one, so only this one. So that's one kind of a training process. So it can learn their training process. I say again, for the training, they do this one and fix the parameters and do second and do four. If you right now, after 3 stages, the results, okay, I stop. But for the test, remove this one, only keep this one. So for the test is input, and here's output. 这样子，因为它比较复杂，可以这样做。对，这是 for。Still have time. GoNet. What's the ResNet? ResNet is this one. So we have a shortcut here. So ResNet we call residual. What's the residual? Basically, it's a shortcut. So originally here, but residual is a shortcut. So we see this example, ResNet. Again, for each downsampling, we do the cut. So there were one downsampling here, cut it, 2. Sorry, 1 here, 2 here, 3. Sorry, 1 here, and 2, and 3 here. Different color, 4, 5 different. See this here, pulling downsampling. 1, 2, 3, 4, 5. So they have a 5 stage or 5 block. And times 2 is meaning they repeat 2. Times 4 is meaning they repeat 5. Okay. Now, why they want to do shortcut? It's because if the input image, the texture for the input image, it doesn't know. So usually, if they have a more texture here, you can extract more information and go through more layers. That's good. That's a good one. If your input image has less texture, you go through here, probably up to somewhere, there's no texture anymore. That's the problem. If you have more texture, okay, the image has more texture, you can pass through more layers. They can extract more information and self it. So here's more information here. But if you have a less information, up to somewhere, there's nothing. You cannot continue to extract. So what can we do? So that's why we need shortcut. So that's meaning if we have a more texture, okay, you can pass through more layers. If you don't have a more texture, they will automatically, suppose come here and ignore the shortcut here, ignore this one, go through and shortcut here. So they don't need to pass so many layers. Okay, so that's meaning, so this more robust. No matter what kind of image you input, I can automatically handle it, and the result should be better. He's right. So ResNet has better result than VGG and GoNet because they have a shortcut. Okay. So they do test. This is some. So originally they call this plan here AI plan. So suppose we have 34 layers without shortcut. So here the same. This is original VGG19 here. So we cut. So for any pooling or downsampling, we cut. So cut here, 2, 3, and here 4, 5. So they have 5 downsampling. VGG19 has a 5 downsampling. How about ResNet, which downsampling 1, is then 2, right? 3, 4, 5. The same, they have 5 downsampling. But for each downsampling, there are many layers. 你发现都一样，都5个 downsampling， 这样子。那这里要跟你讲是说 ，here plain is meaning they don't have a shortcut, and relative meaning they have a shortcut, and they prove this result is much better than this one. That's what I said before. So people right now we use the shortcut in many cases. Okay. The final one is here. See, VGG, they use 1, 2, 3 layers for the network, for the classification. But for ResNet, they only use one layer. Why? Because this more deep. 2 purposes. The first purpose is because they already have enough extraction layers. They have many parameters. So they try to reduce the number of parameters. ResNet, they try to reduce the number of parameters. So here they only have one network. Here. The second is because they already extract enough information. Extraction is meaning between here, they have an activation function. So they not only extract the information, their activation function will move to the other space domain or space. 因为它有 activation nonlinear discrimination 嘛，所以它这个 nonlinear discrimination 够多了，它已经帮你把它分得很开了，所以到最后分类的时候就很容易分类。Because they have they're deep enough, so they not only extract the information, but they have an activation function to do the nonlinear discrimination. So up to here, all the classes already separate. So they're easy to do only one layer and one network to do the classification. So that's the advantage of deep. Deep 的好处就是它很多，它就帮你慢慢分，把它推开，分类分好了，不，那个空间分，帮你推好了，所以你后面很简单就可以把它分类分。那这个不够 deep 的话，你只要在后面要用更好、更强的 network 把它分类分，是这样子。所以这边不用再分，不用再那么复杂。那后面这边一样。REST2net is trying to be wider. So I will explain this one later. So you'll find many methods that combine the Google Net and the VGG. The concept is one more deep, the other is more receptive field is more wider. So I will keep talking, explain this one. And up to here is at the end the result. So we will finish talk to here. So next week we will continue to talk about this bounding, but the more important application is for detection and segmentation. This one is for classification, for extraction and classification. And this one is for more powerful for the detection, including bounding box and classification. We will keep talking about this. Okay, that's for today. 谢谢啊，我会继续留下来。那有问题你在线上持续问啊，先下来，谢谢。